Okay, practice problems. Anybody have a problem with one?
Wait.
Well, that depends on what the answer is.
I don't know what the answer is.
I would, but you took your answer key right before I got to that.
Where's the answer keys over here?
Wait, so would 1,000 milliliters be 1 liter? 1,000 milliliters would be 1 liter, right?
I don't remember if I did. Practice problems, module 13. Okay. Okay, so we're trying to calculate enthalpies, the amount of energy released during a chemical reaction. And so, remember there are 3 ways to calculate enthalpy: using the equation, using bond
What's
energies,
the equation?
Q, I don't know, where is my notebook? Oh, hey, this
Wait,
is
what
my-
if you didn't give us an equation?
Equation?
Wait. The delta S equals S product minus S reactions. Nothing.
No, that's the equation for delta S.
That's the only equation I have. Oh,
What?
what is energy over moles per calorie?
Those are the units.
Wait, so would the answer to these be just moles of HCl? 2.06 moles of HCl. What is that about? What?
Capital molarity.
Molar.
Aren't you using volume using?
What's that equation, Beebs? You get that? Where is your notes?
Is it,
Oh, Q equals MC times delta T.
Wait, what equation is that for?
Q equals MC times delta T. So Q is the energy, M is the mass, C is the specific heat for the substance, and the change in temperature is the change in temperature. So it's energy is equal to the mass times the specific heat times the change in temperature.
Can you write that down?
Thank you. Delta T. But there were no problems for that in the practice problems. So that's the first method, right? The first method is using this. This is the experimental method, right? This is where you actually have to react the ingredients together, the reactants together, and measure this delta T. Right? The other way is using bond energies. Right? Bond energies, and that's the reactants. Reactants minus the products. Right, so you've got to take a look at your reactants and calculate the energy released when you break their bonds, and then subtract the energy released when new bonds are formed. And then the third way, using Hess's law, and that's Hess's law, and that is enthalpy, using enthalpies of formation. Enthalpy of formations, and this comes from a table. Right? In order to use Hess's law, you have to know states. Right? So gas, is it a gas? Is it a liquid? Is it a solid? Is it aqueous? Right? You have to, in water, dissolved in water. So you have to know, these things have to be given to you in order to use Hess's law. If you don't have these things given to you, you have to use bond energies. If you don't have bond energies, then you've got to use this. You've got to go out, get the ingredients, react them together, and figure out what this delta T is. So let's take a look at number one. What's going on with number one? The chlorine smell of a pool water is not, in fact, due to chlorine.
It's due to impurities like
What- When chlorine hits the water, some of it reacts with the water in the following manner. 2 moles of chlorine react with 2 H2Os to form 4 hydrochloric acids plus 2 O2s. Now, we have to figure out what the enthalpy is, right?
I cannot see the board.
What is the delta H for this reaction? Right, so it wants us to calculate the delta H for this reaction. How much energy does this reaction produce? We can go out, buy these ingredients, react them together, and measure the temperature change.
What problem was
Number one. Number one on page
that?
457.
110 kilojoules.
Is it? I don't know. Maybe it could be. Oh, it is. You're right. Good. So, we don't want to do that. Absolutely not. Could we use Hess's law?
Yes.
Why can we not use Hess's law?
You don't have to say so.
Yeah, there are no states. Right? No states. Right? How are we going to use enthalpies of formation when there are no states present? Right? We don't know that this chlorine is a gas. Probably the chlorine was a gas, but we don't know that for a fact. Probably the water was liquid, but we don't know that for a fact either. Right? So what do we got to do? Bond energies. James Bond. Right? We got to use bond energies. We've got to find a table of bond energies, and we got to figure out how much energy does it take to break a chlorine-chlorine bond. How much energy does it take to break a hydrogen-oxygen bond? We got 2 of them. And then how much energy does it take to break a hydrochloric bond and an O2 bond? Yep, easy peasy. What else do we have problems with?
8.
8, okay, this is the math thing. So here we go. We're given, if the delta H of a certain reaction is negative 1023 kilojoules per mole, and the delta S is negative 324 kilojoules per mole, get myself on film here so people can enjoy my presence, is negative 324 joules per mole degree Kelvin. What is the temperature range for which this reaction is spontaneous? Spontaneous reactions. What rules spontaneous reactions?
Oh, it means negative. Wait, no, that's not good.
It has to be negative.
Spontaneous is triangle G
Delta
equals
G.
negative equals spontaneous.
Did I miss
Yeah, what do
a
we
week
call
at
that?
some point?
What? Oh, that Gibbs.
Gibbs free energy. Yeah. In order for a reaction to be spontaneous, what has to happen? What does Gibbs free energy have to be?
Has to be positive. I mean negative, yeah.
Negative. Has to be negative. Okay. So they gave us delta H, they gave us delta S, they gave us no temperature, but we know what? In order for this to be spontaneous, it has to be
Negative.
negative. So we're going to just make up our own formula. No, we're not. What's the Gibbs free energy equation?
Products minus.
Oh no, wait, Gibbs.
Oh, wait.
Gibbs free energy. No, I want the equation.
Wait,
Delta G equals delta H minus T minus delta S.
Minus T times delta S. Alright? They gave us what? They gave us delta H. Woohoo! They gave us delta S. What is delta S incidentally?
delta S is measuring entropy of a chemical equation.
Yeah, delta S is entropy.
Wait, I thought you said there were only 3 ways to determine it, and that is not.
3 ways for enthalpy. Enthalpy, what are we doing? We're doing Gibbs free energy now.
Yeah.
All right, so we don't know what delta G is. We know what's delta H? What was the number?
There's a number?
What did they give to us?
Oh.
Delta H of the reaction is negative 1023 kilojoules per mole. Right? Minus T, which we don't know, but we do know delta S. What's delta S?
Entropy.
On the equation, what's delta S? What did they give us?
Oh, I don't have
Hey,
a book.
negative 323 joules per mole degree Kelvin. I'm just plugging and chugging. They gave us this, they gave us that, that's this and this number. We don't know temperature, but we know all this has to be what? When you add all this together, what does it have to be? For it to be spontaneous.
Negative.
Negative. And delta
Okay.
G.
What? How can we give a relationship? How can we show delta G being negative here? It has to be what? In order for a number to be negative, it must be
Spontaneous.
less than
The other.
0.
Zero.
less than 0. Right? So all this has to be less than 0. Right? Because if all this is less than 0, it's going to be negative.
Definitely.
And if it's negative, it's spontaneous. Now, and this is where some of you don't have the math yet. What are we going to do here? We got to get T all by itself. Well, first of all, we got some odd stuff. We got joules over here, we got kilojoules over here. So we need to convert this joules into kilojoules. Right, so I'm just gonna do this in my head. So T times negative 0.324 kilojoules per mole degree Kelvin. Everybody agree with that?
Yeah.
You agree with that, Katrani?
Yeah, sure.
All right, there you go. I'm gonna put a 0 out front here just to make it more obvious. All right. Okay, so now we got to get T by itself. What are we going to do? Well, gosh, we're just going to add 123 to each side.
Wait, that's 1,000 to.
I'm sorry, yeah. 120, yeah. Right, yeah. All right. Negative T times negative 0.324 kilojoules per mole degree Kelvin. All right, we're almost there now. What do we need to do? We need to divide through. Where you at? You're off someplace. It's like, oh, I'm going to be doing this in about an hour and a half. I'm really going to be enjoying myself. I'm like, what's going on now? I'm being tortured. What are we going to do? How are we going to do this?
Multiply those sides by 0.324.
Oh, good grief. Right? Is that what we're going to do? Divide both sides by 0.0324 negative? Yep. That's going to cancel that. It's going to cancel out. We're going to come over here. We're going to multiply by negative 0.324. And this is where the tricky math comes in. Whenever you multiply or divide by a negative number, you got to do what?
Those sums.
Well, yeah, you do both sides. What do you do with the sign? You flip the sign. Right, so we got to flip the sign.
Change the sign.
Right, some of you haven't had that yet. You got to flip the sign. Right, flip the sign.
I feel like I learned that 5 years ago, that's why I don't remember it.
Multiply whatever that is, you multiply.
There's some saying there can't.
I
it's
remember
change-
it.
Cross the line, change the sign. That's what it is.
Yeah, that is it. That's
Cross
it.
the line.
The
change
line
the
would
sign.
be the equal sign. So like
Yep.
in algebra, if you
If
cross.
you-
Well, that only works if you multiply or divide.
That's just what they taught us in the
Oh
school.
no.
Great. Awesome. Well, you'll be right 50% of the time.
You don't think, just do. That's what we're
Excellent.
taught.
Yeah, that'll,
Nope, they
yeah.
just-
You'll make a fine soldier.
That's what Hitler
Join
said.
the army.
math book tells me, like, develop this formula. I know the formula. I don't need to know how I found it. I know the formula. I don't need to know
No,
how I
derived
found it.
formulas, oh yeah, those are killers,
So
I hated those.
annoying. Like the identities. Oh, trigonometric.
Proofs, have you had proofs yet? Proofs
Oh
are
my
fun.
God.
Yeah, that was in 8th grade.
Geometry,
Stupid.
trigonometry. Okay, so that's, any other questions?
No, are we dismissed?
That's funny.
Yeah, not that many questions, Greg.
So for 6, what is the sign of delta S for the following reactions?
Easy.
Yeah, those
Positive,
are-
negative, negative. Right?
We do.
Is it positive, negative, negative, positive?
The first one's positive, second one's negative, the third one's negative.
Second one's positive?
No.
You should probably change it.
Positive, negative,
Ah.
negative.
Okay. Alright, so get those to me. Now, this is the plan stand. We've got
No tests left? Or all of
We're
them?
done.
We've got,
What
no, we've got kinetics. I want to cover kinetics.
is
Kinetics,
that?
kinetics is fun. No, so thermodynamics tells you how much energy is released. We don't like thermodynamics.
No.
Kinetics tells you how much product you're gonna make. Well, that's kind of useful. All right, so
Easier to grasp.
I want to cover kinetics. Then what we're gonna do? Everybody like goes or leaving, coming and going. They're gonna be missing classes at random. I don't know.
We want.
Because of the scheduling. So after we cover kinetics, we'll test on kinetics, and then we're going to do probably 2 to 3 weeks of
We didn't
review.
have that much left.
Review. We're going to, yeah, we're almost finished. We're going to do 2 to 3 weeks of review. We're going to start all the way over,
Awesome.
and we're going to
Are we
go.
doing final?
What?
Round.
No.
Final!
Are you serious?
Woo-hoo! An entire year of chemistry in one test. Oh, what could be more fun? I can't think of anything.
Death.
Can't think of
I
anything.
think I'm gonna be
Death.
sick.
Can't think of
I'd
anything
rather
that
jump off a
could
bridge.
be more fun than one comprehensive fight.
Dante's
Please
Tower.
tell me you're kidding.
No!
Oh.
John, is he kidding?
Comprehensive.
No. Wait.
What fun!
Wait.
No wonder
What
so
fun.
many teenagers are suicidal.
All right. Okay, so we'll go through 2 or 3 weeks, and it's gonna be big concepts. I mean, obviously, if we're doing an entire year on one or one test, I can't get down to the minutia of detail.
Can it be open book?
Okay, what I can ask you is like, what two types of molecules are there?
Hold on, hold on. Wait, no.
Okay, no, well, okay,
Ionic,
there's yeah, I'll have to formulate it in such a way where, what kind, 2 types of bondings, what are the 2 types of bonds that we have studied?
Ionic.
Ionic and
Covalent.
covalent, right? Give me an example of an ionic bond.
A metal and a metal.
Metal, no, metal and metals never get
Non-metal
together.
and non-metal.
Metal, non-metal. Covalent bonding are 2
Non-metal.
non-metals. We're gonna test multiple ratio, obviously. We are so good at multiple ratio.
Are we?
No,
I
I
don't
don't
even know what
know.
multiple ratio is, y'all.
Melon.
I don't
say
like
things like that.
I hate balancing equations.
I don't
Oh, I
mind
don't
that.
mind that.
See,
Oh, speaking of that, there was a hairy
Oh, I have an
balance
idea.
equation.
Why don't we have one test and all of us work on it together?
Yeah.
Yeah,
We'd be good at that.
we would.
I bet y'all get 100.
I'll do the doodling.
I will write our names.
Yeah. I'll grade it.
How much is the-
What's that balanced equation?
No.
How much is the final gonna be worth?
100%. No, no.
2 regular tests.
Okay, take a look at number 2.
Can our mothers
I don't want
take
you
out of
wasting
this?
your time. On number 2, on page, whatever page we're doing. Those of you that have not done the questions yet.
Number 2, on the practice problems?
Yeah, practice problems.
Oh, I did it.
You balanced that? What did you, why not supposed to balance it?
What?
Did you balance that equation?
Yes, I don't.
What do you have for
I
2?
have 2 in front of C6H6, then I have 15 in front of O2. Oh yeah, I remember balancing this thing. 12 over CO2 and then 6 over H2.
Wow, good job. That was a hairy one to balance.
Extra credit for please. That took like 10
Great.
minutes.
It's
I
just one
bet,
of the
yeah, that was-
problems.
That was a hairy one.
You're
You
trying to
didn't
get
do it.
extra credit for doing something
Yes,
right.
Candy just said he didn't want us wasting our time on it.
Yeah. All right.
So,
So very good.
Extra.
So yeah, those of you who didn't, it's 2 benzenes, 15 oxygens, 12 carbon dioxides, and 6 waters.
Wow.
And then use that to go on with the rest of the equation,
Wonderful.
the rest of the
It
problem.
took so long to get that.
So there's going to be some of that on the final. What else have we talked about?
That's all.
Is it?
That's all.
There's been a lot of content in class. We
We did, remember
Oh, the
electron
gas laws.
electron orbitals?
Oh yeah,
Let's do
the
gas
gas laws are my
orbitals,
favorite
S
thing.
orbitals, gas laws.
Gas laws are the best. Can we just have one test on that?
We already had one test.
Yeah.
Let's do another one.
Yeah.
Um,
All right, let's look at kinetics. Okay, as I said, kinetics. We're looking at the amount. We're looking at reaction rate. How quickly is this product formed?
I have a question.
Yes.
Can we do a lab? We've only done 3 labs so far.
Great.
I'm pretty sure.
Yeah.
And
I think we've done one of that.
I'm pretty sure.
We've done like one.
There's the one that I broke the
outside.
thing. There's the one that we
So-
did.
I was
Yeah,
wrong.
our labs were seriously hampered by losing one of our burettes.
Chris, are you sure it's a good idea to remind him that he broke
Well,
his
then we can just use one. Like, we can
It would
just.
take forever for eight
I'm pretty sure
bloody
there's
young
6.
chemists to do what needs to be done with one burette. Also, don't want to take a chance on using my last burette.
Grace could be bad.
You can just do it for us.
I've done
Just
enough wet
watch.
chemistry, thank you. I don't need any more
Wet
practice.
chemistry, is that what that's called?
With.
Wet chemistry, yeah. Wet bench chemistry. I did it every day for like 60 years.
I think it's unfair to
Hundreds
go
of
over any
analyses a day.
concept when
For
3
60
people aren't
years?
here. Great.
Great. I've been alive.
All right, let's look at kinetics. Kinetics.
How do you spell that?
Our last chapter, kinetics.
For fun, can we put connects?
That's what I'm thinking of every time.
Okay, so with kinetics, what we're looking at is reaction rate.
Molecule things?
Yeah,
Oh, that's a big
for
part.
molecule things.
And the reaction rate is the amount of product formed.
Okay, wait, so tell me what kinetics is again?
Right
And
here.
it's like
Wait,
the
yeah.
measurement
The
of how
amount-
much you can make or something like that.
Yeah. The amount of product formed per unit time
Wait, is that the definition?
of reaction rate, yeah.
No, can you give us?
It can also be, what else could it be? If it's the amount of product formed, right? If we have reactants, products, if it's the amount, the reaction rate is the amount of products formed, what else could this be related to? What?
Chemistry? What?
So deep, Chris.
The amount of products formed or the amount of,
React. Form.
Use.
you don't, consumed.
Consumer.
So the amount of products formed per unit time or the amount of reactants.
What, can you give us the definition of kinetics? So we can-
Kinetics is the study of the amount of, it's the study of reaction rates. Kinetics is the study of reaction rate.
But I thought it was measuring how much product.
But that is what reaction rate is. So indirectly, kinetics is the amount, figuring out the amount of product per unit time, or the amount of reactants consumed over a unit time. Typically, you don't really see it defined, or you don't figure out the reactants. No one really cares about reactants. The only people care about is products. What am I making here? I don't really care what I'm consuming. So typically, it's this one that we look at. And we can give it a sort of a definite, or a equation. We'll call it big R is equal to,
Wait, big R equals moles, oh wait, that's in.
no, little r.
R
Little r
equals-
is the reaction rate constant, but that's not this. All right, so R is equal to the change in the concentration of product. Look at all these abbreviations we're getting. Divided by, what do you think?
Product reaction.
Unit time, which we're going to call what? What's change in time? Change in time is?
Distance over rate.
Physics doesn't come into chemistry. No physics in chemistry. What do we call change in time? What's the chemistry term for change in time?
Clock.
Delta T. Hello.
Oh, okay.
When did we go over? Oh.
When did we go over delta T? No, you weren't going to ask that, were you?
Yeah.
When did we talk about ionic bonding?
Long time ago.
When is our finishing date class?
How many weeks do we have left? Does that include regionals? Because Grace and I might be gone, and Lynn.
Yeah, that's
Yep,
what people are
we
going
might
to
be
be.
gone.
And then I'll be gone for 2 weeks.
No,
After
that's
that.
spring break week. We are not having.
We're
full
probably not gonna have spring break.
No spring break.
Honestly, I would rather
Spring break?
so that we can have summer break.
Your spring break is getting to learn more about chemistry. What?
No.
What could possibly be
Well,
a
our
better
spring
spring
break
break?
for worldview is
I
actually just
asked
like
my dad to
doubling
tell
our
that
work.
Tuesday at the beach because that's what my friends do.
Grace, what do we have to do over
You
spring
have to
break?
read Pilgrim's Progress and start working on a PowerPoint.
What? What?
PowerPoint?
We have a PowerPoint?
Just look at the homework schedule.
What?
I haven't looked at it.
No, we've given like 3 presentations in class already.
Actually, just one.
I'm quitting. I'm just quitting.
I'm
I'm quitting.
Get every day.
In 8th grade, I had to do a
I'm
PowerPoint
quitting school,
presentation.
y'all.
That was so fun. I still have it.
No, I'm not even. I'm just gonna try to get out of this. Like,
What I did.
Grace is gonna get her
Alright.
GC.
High school dropout.
Stage drop.
Can we boycott
Our life.
this? What, John, what is your PowerPoint? Is it
I
like,
think it's like culture.
Everyone get
it's
this?
like what?
We
So,
good?
yeah, so
Renaissance culture.
Oh no.
we
Did
don't
you,
have like 4 weeks of
did you
class
understand
left?
what I put down there as far as the, it's the delta this, product,
Yeah,
unit, okay, you understood. We know what these, that's concentration, that is a shortcut or a chemist's abbreviation for concentration, right? Whenever you see this, it's concentration.
oh, I didn't get that.
All right, so it's a change in the concentration of the product over time. Over delta T.
Concentration of product?
Yeah. The amount of product, the concentration of product.
So we
And
have, like,
actually, it's moles per liter per second.
So do we
That's
have
the units.
like 4 weeks of class left?
That's what I'm guessing.
Because we'll be gone I'll be gone for 2 weeks to Europe, 2 days after regionals.
Oh, well.
And we leave probably on Tuesday
You'll be
for regionals.
in Europe doing your comprehensive chemistry exam.
I get to miss a
That's
little
gonna be
class.
awesome.
That's my
You can go to the birthplace of chemistry, go to Germany.
No, we
China.
already went
But-
there.
Who's like the father of demonstration?
Satan.
Me.
Who's the father?
What is it? Dalton, I think would probably be considered the father.
Just Bacon.
Bacon?
Physics.
Roger Bacon? He was a
Fred, no.
Bacon.
Francis Bacon.
It's all the same. It's all the same.
I don't know, but it's tasty on a sandwich.
Delicious meat.
Okie dokie. So let's take a look at this.
I'm searching it because I know this.
4 things that affect reaction rates.
4.
That affect, is it effect or affect? Affect
It's
reaction
I don't know.
rates.
Francis Bacon.
That sounds like a vlog title.
Francis Bacon.
4 things that affect reaction rates.
You should start a chemistry blog and we would all thank you.
All right, first thing. Let's just take a look at it. So we got, let's just make it generic, A plus B goes to C plus D.
What
Okay.
is all that?
It's just a made up reaction. All right, so I got so many moles of A, so many moles of B, so many moles of C, and so many moles of D. Here's my product. Here's my reactants. What would affect the amount of product formed, do you think? Just brainstorm. What do you think it's going to possibly affect you?
A and B.
A and B, yeah. The amount of reactants. So the concentration of reactants.
Wait, what's this? Wait, 4 things.
4 things that affect reaction rate. What else?
Temperature probably?
Temperature. And usually, if you increase the temperature, you increase the reaction rate. And for concentration of reactant, typically if you increase the reactants, you increase the reaction rate. I guess I should write that down. It's kind of obvious, but I'll write it. Increase reactants. You increase reaction rate.